Hello everyone, welcome back to another lecture. This lecture is going to be an optimistic one from the set of sections, chapters we're going to cover. Um, you know, it, in one way you can say it's a lot, but they're all very related. The inheritance chapters are very much related. The 12th and 11th or 12th or 12th or 13th, those two. Those are closely related because inheritance, polymorphism, virtual functions, abstract class, they all have um, a lot to do with each other. Okay, so that's why I'm going to cover inheritance in one go, and then we'll talk about file processing, and then stream input output would be at the end, or I might reverse it depending on how the flow of information is going and how I feel. So without further ado, let's get into inheritance. So what is inheritance? Inheritance is the key concept, um, is one of the key concepts, the other one being polymorphism, is what makes the object-oriented programming, what makes it special, what gives it the power. Okay, so in this, what you can do is you can derive something from a base class. What I've got here um, is an example. A famous one that people tend to use is a shapes example. You know, base class is shape, and then square is a shape, rectangle is a shape. To demonstrate is a relationship. I've got an animal example. Okay, so there's a class called animal. It's got two functions in it. It's got eat. It's got sleep. Okay, so that's gonna serve as a base class. Simple. Now, if you want to derive something from it, you say class dog colon public animal. We're going to get to the type of inheritance, but that's how you derive a class. So what ends up happening is a dog is an animal. Now dog, it's an inherited class. It has a bark function, but there's a but to it. Since it's inherited and it's an animal, it's going to have all the functions of the base class. So what you end up doing is you have all the qualities, data members, functions of a base class, and on top of that, you get to add more to it. So it makes C++ object oriented, makes it a lot more cooler. So this is what happens, right? This is what I was trying to tell you. You got the animal class with two functions in there, and dog derives from it. Let's jump into a few examples right here. Okay, so here, let me show you what I've got here. So I've got a base class called animal. It's got a method called eat. It's got a method called sleep. And then this one, dog, has a method called bark. Now, I've got dog, and then I call the method eat, sleep, and bark. Well, let's see what happens. I can eat, I can sleep, I can bark. Woof, woof. So even though you explicitly didn't declare the eat and sleep method in dog, since it was inherited, you get those functions for free. So that's what this is demonstrating here. Anything else do I want to cover? Well, let's walk through um, another slide here, and then I'll go over the example. Now there are three different types of methods, right? We know that, and inheritance. Well, before we get into inheritance, different types. There are three different types of protection available. Okay, there's a public protection. It could be a method, it could be a data member, and then there is private and protected. Three. Public, if a data member or a function is public, anyone, and I mean anybody from outside the class can access it. A friend, non-friend, derived class, non-derived class. Okay. Private, only the class can access it. Okay? If it's a data member or a function, it's only accessible within the class. The derived class cannot access it. No one outside the class can. Not even the driver. Not even the derived class. Protected, it's a unique one because that's how you get access to your base class properties, methods, etc. If it's protected, the class and its children and its inherited classes can access it. I tend to call it children. Sometimes you'll hear me use that terminology, but you know what it means. Children is the inherited class. I call it a child, right? So you've got a base class, inherited class. Inherited class is a child of the base class. So protected, that's what it means. Okay, and you can also have a type of inheritance, class animal. Okay, and then when you derive from animal, private animal. Now what happens? Um, Let me talk through some of these. Um, you can also have it protected. So you can have public inheritance, protected inheritance, and private. If it's public, if a derived class is declared in public mode, then the members of the base class are inherited by the derived class just as how they are. No problem with public is more intuitive and you can understand it. Straightforward. Private, all the members of the base class become private members in the derived class. Okay. Protected, the public members of the base class become protected members in the derived class. We'll walk through some examples. Hopefully that's gonna make things clear for you. But before we do that, let's look at a slight difference here too. Public inheritance make public members of the base class public, and the protected members of the base class remain protected. Okay? Protected inheritance makes the public and protected of the base class protected in the derived class. Private makes the public and protected members of the base class private in the derived class. Let's go to the example. Okay, so here I've got a class called animal, and then it's public inheritance. Okay, and the class animal has private and a protected member, and it's got public methods. Eat, sleep, set, color are public. Color is private, type is protected. Dog derives it has a public derivation of animal. Okay? See what it does now. So it's public, it says set type. Okay? Display information, it takes in the string and it displays the type. Why is it accessing type? Because it's protected, and protected members and data members of the base class are accessible by the derived class. Okay, so that's why it's able to set up the type. But it's not doing that with color, right? Because color is private. See, set color, it calls set color, and set color is a base class function. So dog1.e, dog2. Come on. No, these pop-ups. Close these. So dog1 eat, dog1 sleep, set color black, bark, and then set type. Now look at all these eat, sleep, set. Eat, sleep, they come from animal, and so does set color. Dog does not have a set animal. Now bark, it has a method called bark, and set type. It does have a set type because, and why is it able to do that? Because the type is protected, right? And if you run this, it says I can eat, I can sleep, I can bark. So what you should remember from this example is the protected is something accessible by the derived class. Okay? Private is something that's not accessible by the derived class. let's move on to a different example. Um, this, I'm not going to run this example, but this will explain to you the different types of derivation, inheritance. So I've got a public derived class. Well, it's a base class. Then I've got public derivation, protected derivation, and private derivation. Okay, so if it's public derivation and base has got x, y, and z. See what happens if it's public derivation. X is public because it was public in the base class. Y is protected because it was protected in the base class. Z is not accessible at all because it was private. Okay? Now, if you do protected derivation, what happens? X was public, X becomes protected. Y was protected and it stays protected. And Z is not accessible because it was private. And if you do private derivation, the public and private X and Y, they end up becoming private here, and then Z wasn't accessible to begin with. Now, what do you think is going to happen if you derive something further from like a private derived? Private derived has a child. Well, that child isn't going to be able to access X, Y, or Z, because once you came to this sort of derivation right here, you made it private. Another example of private protected. You've got a private member, you've got a protected member, and you've got a public member. And then PVT, this returns a private. This I'm going to do public derivation. Get PROT returns PROT. What is PROT? Where is PROT? Do you see it anywhere? It's right here. It's protected, right? So this one should have access to it. Private, protected, public. Object1.get PVT, object1.get prod, object1.pub. Pub because this was protected, it still had access to it. Get prod is going to return the private method. So the pub and the PVT is something that public derived is going to have access to, and also the protected. Okay? Now, as we're kind of skimming through these, sorry about the background. As we're kind of skimming through these, it's easy to lose track. Now, what you really want to do is have a cheat sheet. Have a cheat sheet that's going to help you with these scenarios. The cheat sheet that I was talking about is this right here. Come on. Okay. So I've got these 3 slides here. Accessibility in public inheritance, private, and protected. So this is kind of your cheat sheet. Okay, write it down somewhere and try out a few examples. It's going to end up making sense to you. So if in the base class you've got a private member, derived class has no access to it. That's easy. Protected, yes you do. Okay? Public, yes you do. Public, like I said, this ought to be intuitive, easy for you to understand. Private, base class has private member, derived class has no access to it. Private is the highest level of protection. And then protected member, yes, the derived class access to the protected members, but in the derived class they end up becoming private. And if you have further derivation from the derived class, if you have a derived class from this one, that derived class is not going to have access to this protected members if it's a private inheritance. Okay? Public member, yes. It has access, but then it becomes private. And if you have something further derived from the derived class, that guy's not going to have access to the public member, okay, nor to the base class protected member, nor to the base class um, private member. So access stops there if it's private inheritance. Protected, what happens in protected? Public members end up becoming protected. Protected stays as protected. Private stays as private. Okay? So the most confusing might be private for you. Protected, public end up becoming protected. Keep that in mind. Where were we? All right. Do I have a... Okay. Let's talk about the protected derivation. So you've got a base class. You've got private, protected, public members in there. And then you do the protected derivation. In here, I've got a get prot. It returns prot. Okay? It returns this. Since you've done protected from base, what's going to happen to private? Private stays private. What happens to public? Public becomes protected. What happens to protected? Protected stays protected. Private cannot be accessed. Get prot returns prot because it was a protected member. Get pub return pub because pub was public. Pub and prot. Prot and pub. Protected and public. Public derivation, right? Now, let me mention another thing here before I go to the next thing. Constructors and deconstructors. So you get a constructor in the base class, you get a constructor in the derived class. If you don't have it in either or, compiler is going to provide one for you. But keep this in mind. When a class is constructed, so you've got a derived class, when you construct the derived class, the base class constructor gets called first, followed by the constructor of the derived class, right? Because you're going to build up the base first and then you derive yourself. So when you build a dog, it's going to build a animal and then the dog. But destructors is the opposite. When you end a program, the destructor of the derived class gets called first and then the base class. Okay? So when you complete the main driver for the dog class, right? You're done with using the dog class. The dog class destructor is going to get called first, okay, and then the animal gets called next. Keep this in mind, okay? It's opposite for constructors versus destructors. Virtual functions. Continuing on. What is a virtual function? Do you need the keyword virtual in there? Now look at this example. I've got a base class, I've got a derived class. And both of them have the function print in there. Now watch what happens with this kind of... So if I do this. So I had this in there, derived class, right? So then I did derive 1. And then I made the derive 1 point to base. Oh, I'm sorry. Yes, I have a derive 1 class, and then I have a base pointer pointing to derive class. But when you call the base 1 at print, what do you think is going to happen? Well, this is to say, I'm sorry. This is what I wanted to show you first. So I've got a derived class and then I've got a base class pointer. I can make the base class pointer point to a derived class. That's no problem whatsoever. But when you do base one, come on. When you do base one at print, well, even though you're pointing to a derived class, base class is getting called. To get away from that, we use a few key words. And watch what happens. I'll do without it. Right? Derived class. Now it's working because you've got the keyword virtual in there. So virtual is a special method that the derived class is going to override, and then when you use pointers, you can expect the right function to get called if you've got the and typically that's all you'd go. You'd have a point. You'll have a pointer to base class, and you'll point it to a derived class. I have another example of. Well, that's the same one, isn't it? Okay, virtual. Next up is virtual destructor. What is a virtual destructor? Destructor has the same name. We talked about it, I think, in the past. It's got a tilde to it. And now we know the derived class destructor gets called first and then the base class. What's a virtual destructor? When a derived class involves dynamic memory allocation, we have to deallocate the memory in the destructor. I'll show you. We'll talk about some examples. And then the next thing we're going to talk about is the abstract class and pure virtual functions. Now consider this example. So you've got an employee class here. It's got private members. It's got public methods in there. It's got a virtual method, and it's got a virtual destructor. Declare a vector to store employee pointers to a derived class. Now, I'm not deallocating any memory in here, but hold on. Just look at the syntax for now. Okay, let's focus on the syntax. There's a usage of vector in there. There's a class employee. Okay, and then there is a class hourly employee. And then there is a regular employee. And look at what I'm doing here. I've got a vector of employee. It's a base, it's pointer to the base. Then I create an hourly employee, and then I create a regular employee. And I do print wage. And each print wage is a virtual function. Right? And it gets overridden in the derived class. So that's why you get hourly wage of John Doe is this, and hourly monthly wage of Jane Smith is this, because one's a hourly employee, one's a regular employee. Now let's look at this example right here. So you've got I've got a class shape. Don't worry about the keyword default in here, but just look at the so I've got a virtual get area method, and I've got a virtual destructor. So the way you make it virtual is you put the virtual keyword in there. Now I've got a square class that derives from shape. It's got a private member in there. It's got a pointer to a double. Okay, and then for get area, it's gonna do it's gonna return length. And then in the destructor, I want to delete the length. Okay, and when I run this, what in the main function I've got, I create a square. Okay, area of the square is so and so, and then I say delete shape 1. Okay, then I say shape 2 is a new square, and then area of the square is such and such, and then I say delete shape 2. So both squares had different areas. That's understandable because the constructor took in this one was 1.5, this one's 2.5. Now you see this deleted length, even though uh, square is derived from shape. If you didn't have a virtual destructor, what will happen? You won't be able to clean up this memory, this pointer. You'll have a dangling pointer. In other words, you have assigned memory to something, but you have never released it. It can create a memory leak for you, core dump. If you're familiar with core dump, it's fine. If not, that's fine. But there'll be a memory leak somewhere in your program, and then you're going to have a problem debugging it. Okay, so now let's talk about another concept. Is well, one thing I didn't mention is let me go back here for a second. Okay, so virtual destructors I mentioned, an abstract class and a pure virtual function. So look at this example right here. So I've got a class shape. In it, I've got a virtual function, but I've set it equal to 0. Now what this does is this makes this virtual method a pure virtual function, and it makes the shape class an abstract class. You cannot have an instance of the abstract class because once you try to do that, compiler is going to complain that I don't have an implementation for calculate area. And furthermore, what the abstract class does is, specifically for its pure virtual functions, it enforces that any class that's derived from it should and ought to have this calculate area implemented. And a class that contains a pure virtual function is an abstract class. I mentioned this. And I said we also cannot create objects of an abstract class. There is one point of this distinction here. There is a pure abstract class and a abstract class. A class that has all pure virtual functions, okay? So it's a virtual functions equals 0. If that's all it's got a pure it's called pure abstract class. And then a class that has at least one pure virtual function is called an abstract class. So memorize the difference between the two. Let's walk through this example. I've got a shapes class right here. I've got a dimension that's protected, okay? And then I've got a public method called getDimension. And then I've got a pure virtual function in there called float. It's called calculate area, returns a float. Then the derived class, it's going to calculate the area. It can't do that because it has access to the protected member dimension. See this? It overrides it. I shouldn't say it overrides it. It implements it because the base class never had that implementation. And then I have a square class and I've got circle class. Both of these are deriving from the base class shape and implementing calculate area. Enter the length of the square, 12. Area of the radius of the square is 2. Right? Area of the square, area of the circle, they calculate their areas respectively and accordingly. So, in this example, what we had, the shape class is an abstract class, not a pure abstract class, only an abstract class. And the square and the circle class, they're a derived class. Okay, so I could not get to input and output or file processing. I'm gonna have to do that the next lecture. So I'll stop right here, and then we'll pick it up next time.